Okay, here's a look at our review for the electricity and circuits test. Number one, 2 and 3 are actually referring to the same scenario. It says 2 light bulbs are connected in series, and then the same 2 light bulbs are now reconnected in parallel. So you got to think about what's going on in series. There's one pathway, the total resistance, what happens in series, what happens in parallel, and so forth. Okay, when I reconnect those bulbs that were once in series, what happens when I reconnect them in parallel? Okay, the bulbs in series, as I added more bulbs in series, the bulbs got dimmer. But when I reconnect them in parallel, they get brighter. Okay, because the electrons have more pathways to travel to those light bulbs. Each light bulb is getting the same amount of voltage, therefore the brightness, the power is greater. When is the resistance lowest? So just like we mentioned, if I'm adding new light bulbs to my circuit in parallel, I'm adding more pathways to that circuit. Therefore, the total resistance decreases. So again, resistance is lowest in parallel. When is the power the lowest? Well, in series, as I add more light bulbs, my total resistance increases, and as a result, my bulbs get dimmer, which means the power is the lowest in series. Number 4, we can infer that a wall outlet is set up as a blank circuit. Well, I know a wall outlet is set up as a parallel circuit, and I know it's set up in parallel because each outlet provides the same voltage. And I know voltage is constant in a parallel circuit. And therefore, since it has the same voltage, it's set up in parallel, it is not necessary to have every outlet filled for the circuit to work. In other words, I can have one thing plugged into my outlet with nothing plugged into the other part of the outlet, and the circuit still works. Number 5, we can infer that a light switch is set up as a series circuit. Okay, and I know this because when I turn the switch off, all components turn off, whether they be light bulbs or lamps or a toaster, whatever it may be. If that switch turns all of them off, then I know it's set up in series. If I'm describing the relationship between Ohm's law, V, I, and R, well, current is I, and voltage is V. If I'm looking at V and I, they are on opposite sides of the equal sign, which means that they are directly related. And if I look at current and resistance, I and R, they're on the same side of the equal sign, being multiplied by each other. That makes them inversely related. Okay, moving a little further down. Number 7, 8, and 9. Which type of current flows in one direction? Okay, if I'm going in one direction, that means I am following a direct path. This is direct current. And the type of current that flows back and forth, that is alternating current, which is something that you would find in your wall outlet. Direct current would be a circuit that was set up with a battery, like we've done in class. And charges will only flow, we talked about this yesterday, if there is a voltage difference. So there has to be a positive and negative. There has to be a voltage difference. There has to be a reason for that voltage to want to move or push those electrons through that circuit. And it'll only work if that circuit is closed. If the circuit is open, there's a gap, the electrons cannot cross that gap. Okay, next page, number 10. Okay, in number 10, I've got a 6-watt light bulb that's plugged into a 120 volt outlet. I want to know the resistance of that light bulb. So I'm solving for R, and I'm given V, and I'm given power. Well, in order to get to R, I need to figure out what variable do I not have here. What is the link between power, voltage, and resistance? And it's current. So you want to find current first. Okay, and if I've got P and I've got V, I can find current by multiplying or setting up my equation. P equals I times V, where power is 6, current is unknown, and voltage is 120. If I want to get I by itself, I have to divide 120 to the other side. So I get 6 divided by 120 gives me I, which is 0.5 amps. So now that I have current, I'm going to use current to find resistance using V equals I times R. So there are two steps to this problem. So V is still 120. I just figured it out. It's 0.05. Let me fix this real quickly. .05 amps, there we go, times resistance. If I want to get R by itself, I have to divide 0.05 to the other side. So I get 120 divided by 0.05, and that gives me R, which is 2,400 ohms of resistance. Number 11, if I have a 6 kilowatt generator that's powering a cell phone for 30 minutes, how much energy is used? So I'm solving for energy, E. 30 minutes is referring to time, and 6 kilowatts is measuring power. My answer needs to be in kilowatt hours. Well, I'm looking at my power. Power is in kilowatts already, but my time is in minutes. My time needs to be in hours. So how do I convert 30 minutes to hours? Well, I'll take 30 minutes and I'll divide it by 60, and 30 divided by 60 is 0.5. So there is 0.5 hours, half an hour. 30 minutes is half an hour. That's my time. So my equation says energy equals power times time. So if my power is 6 and my time is 0.5, 6 times 0.5 is 3. 3 kilowatt hours is the amount of energy that's being used. The next two, actually, let's do this. Let me slide this up here. Okay. So now I have a circuit here to the right. Okay, and it's a combination circuit, which means it's parallel and series. Describe the circuit if R1 goes out. If R1 goes out, this is my battery. If this circuit goes, or this resistor goes out, electrons need to cross this gap. But if this resistor goes out, the electrons cannot get to R2 or R3. So if R1 goes out, this circuit becomes open. There's now a gap. And if there's a gap in that circuit, the electrons cannot cross R1 to get to R2 or R3, this circuit would stop working. If R2 goes out, if this circuit up here goes out, electrons can go through R1, they can't go through R2, but they can go across R3 and back around to complete the circuit. So if R2 goes out, this circuit is still a closed circuit, and the rest of the circuit would continue to work. If R3 goes out, this one right here, well, electrons can go up through R1, across R1. They can't go through R3 because it's out, but they can go across R2, back around, and complete the circuit. So this is still a closed circuit if R3 goes out. and that means all the other light bulbs will still work. Okay, 3 things that can increase the resistance of the wire. This was our warm-up this morning. Okay, if I have a thinner wire, that thinner wire will increase resistance. If I have a longer wire, if I take that wire and I stretch it out and make it really long, it's going to increase the resistance. And if I heat that wire up and make it hotter, then that is definitely going to increase the resistance of that wire. Moving on. Number 16. So I'm looking at the circuit to the right. And the circuit to the right, if I start here, I'm going to follow my pathway. I want to figure out what type of circuit this is. I'm going to go across the first resistor, second resistor, third resistor, and back to my power supply. There's no other way that I can get back to my power supply. There's only one pathway. So because there is one pathway, this circuit is automatically a series circuit. Okay, because it has one path. So if I want to describe the circuit if R1 goes out, here's R1. If this circuit goes out, then electrons cannot cross over. There's no way for them to jump across and get to R2 and 3. This circuit, this resistor creates a gap, and that gap makes that circuit open. And because it's open, the rest of the circuit will stop working. In other words, in a series, if one light bulb goes out, all of them go out. So now I'm asked to find the resistance in R3. So I've got the resistance, the total resistance. I've got the resistance in 1 and 2. I want to figure out the total resistance, the resistance in R3. Well, in a series circuit, I know that I can add up each resistor to get my total. So R1 plus R2 plus R3. Well, if my total is 20 and R1 has a resistance of 6, R2 has a resistance of 12, what is the resistance of R3? And that's simple, because all I have to do is take 20 and subtract 6, subtract 12 more, and I get R3. So 20 minus 6 minus 12 gives me R3, which is 2. 2 ohms. We get 20 minus 6 minus 12 equals 2. Okay? On the schematic, I want to circle the component of the circle where you know 2 of the 3 properties of Ohm's law. So in R1, I only know 1 component. I know 1 there. In R2, I only know 1. In R3, I only know 1. It's 2. I just figured it out. But I do know by the power supply, I know voltage and I know resistance. These are 2 out of the 3 possible components. So this is what I'm going to circle right here. So this is what's going to help get me started in my data table down below. Okay? So down here in my data table, I have all the information from this circuit up here. It's all transferred down here already, where we have our total voltage, our total resistance, the resistance in R1, R2, and I can fill in R3 because I just calculated it here in number 18. So let me do that for you real quickly. So 2 ohms is going to go right here. Okay, and then number 19 says determine the value of the missing property where this arrow is pointing. So if I follow this arrow down here, it wants me to find total voltage, total current, because this is an area where I know 2 out of the 3 components of Ohm's law. I know voltage and I know resistance. Well, let's revisit our equations. Our equations say that V equals I times R and P equals I times V. If I want to solve for I, and I know R and V, I'm going to divide R to the other side to get I by itself. And so I equals V divided by R. Well, if V is 110 and R is 20, then what is I? If I type that into my calculator, 110 divided by 20, I get 5.5. Okay. Now number 20 says, which property of Ohm's law is constant? So this is a series circuit, and what is constant in a series circuit? It is current. So if I know that my total current is 5.5, then that tells me that the current in my other components is also 5.5. This current is constant, so I'm going to fill that in. Okay. Now we can proceed to solve for V. Remember, V equals I times R. If I is 5.5 and R is 20, if I multiply those two, I get 110. So what's 5.5 times 2? That's what's going to go in here for V. So let's calculate 5.5 times 2. That gives me 11. What is 5.5 times 12? That is 66. And then 5.5 times 6, that is 33. So 33 plus 66 plus 11 gives me 110. And lastly here we have power. Power is, according to our equation over here, I times V. If I is 5.5 and V is 110, if I calculate that, then my power is 605 watts. If I is 5.5 and V is 11, when I multiply those two together, I get 60.5 watts. I times V, 5.5 times 66 is 363. And lastly, I times V, 5.5 times 33 gives me 181.5. And if I want to double check everything, 181.5 plus 363 plus 60.5 equals 605. All right, so look at the last portion of our review. I've got a circuit here to the right, and if you look at it, you have a power supply here. And if you're trying to figure out what type of circuit it is, if you trace from the power supply on one side, you want to try to get to the other side, and you're counting the number of pathways. So if I go up this way and down R1, that completes one pathway. If I go down this way to R2 and back, that's two pathways. So right now, because there's more than one, I automatically know what type of circuit this is. But I can also go through the last resistor and back, giving me three pathways. So this type of circuit is, because it has multiple pathways, is a parallel circuit. Because it has multiple pathways. This one has 3. Okay. If I want to remove resistor 1, if R1 goes out, what happens to the rest of the circuit? Well, if this resistor goes out, the electrons can still go up here and down. They can't cross R1, but they can still go to R2 and back. They can still go to R3 and back. So removing R1 still keeps the circuit closed, which means all the other light bulbs are going to continue to work. So this is a characteristic of a parallel circuit, that if I remove one light bulb, all the other light bulbs stay on. They're unaffected. And the next step here, I want to find the missing resistance, which is the total resistance. So I'm given the resistance in R1, R2, and R3. I need to find the total here by the power supply. And I can find the total in a parallel circuit by adding the inverse. So total resistance looks like this. You have the inverse of R1 plus the inverse of R2 plus the inverse of R3, inverse one more time. So in this case, I have the inverse of 6 plus the inverse of 12 plus the inverse of 18. Inversed one more time. When I put that into my calculator, I get 3.27 ohms. So my total resistance for this circuit is 3.27 ohms. You noticed in series, when I added them together, I got a larger number. When I do the same thing in parallel, my number gets smaller because total resistance decreases in parallel. Number 26, I want to circle on my schematic on the drawing up here which component of the circuit do I know two of the three properties of Ohm's law. And Ohm's law is V equals I times R. So where do I know three of these variables? So the only thing I know at my power supply is my total resistance, so that's only one value. R1, I only know one thing, same with R2, but at R3, I know two. I know resistance and current. So here I know two of those three, so that's the part I'm circling. And I want to use Ohm's law to determine the value of that missing component. So if I know resistance is 18 and the current is 6, then I need to find voltage. And I can find voltage using V equals I times R. So if I take my I, which is 6, and R, which is 18, and I multiply them together, I get 6 times 18. Let me scoot this up so you can see. And 6 times 18 gives me 108. Okay, so now I know the total voltage, the voltage at R3. And if I know anything about parallel circuits, I know that voltage is constant in parallel. So now that I know the voltage here, I can fill in the voltage all the way across. So this is 108, this is also 108, and my total is 108. Okay, so I've got my voltage completed. I can also fill in my total resistance. We calculated that up above in number 25, and we said that was 3.27. So I'm going to write 3.27 ohms. Okay, so let's see. Our next step can be finding current. If I know the voltage is 108 and the total resistance is 3.27, I can find I. And I is V divided by R. So if I take V, which is 108, and I divide it by my R, which is 3.27, I get a current of 33. If I do the same thing here, 108 divided by 18, I get 6. 108 divided by 12 gives me 9. And 108 divided by 6 gives me 18. Got the wrong units in there. Okay, so 18 plus 9 plus 6 gives me 33. And my last step is to find power. And power is I times V. If I is 33 and V is 108, when I multiply I times V, I get 3,564. When I take I, which is 6, and multiply it by 108, I get 648. When I take I times V, 9 times 108, I get 972. And lastly, when I take I times V, 18 times 108, I get 1,944. And these are all measured in watts. I left that off because the numbers were large. I didn't have enough space for that. But I can check my work. If I have 1,944 and I add 972 plus 648, I get 3,564. The inverse of 6 plus the inverse of 12 plus the inverse of 18, inverse again is 3.27. 18 plus 9 plus 6 is 33, and voltage is constant.